Today I am going to talk about a very important topic, that is, what are confounding variables? What are covariates? What are control variables? So you must have come across all these terms, but I am going to explain to you how do these terms arise? What is the basic fundamentals behind them? Understanding the measurement error and prediction error. So stay tuned, keep watching. So what is a measurement error? As I have shown in my previous videos, you might like to go back and check on my previous video wherein I have explained measurement error and prediction error in context to covariance based structural equation modeling executed via IBM SPSS amos. Now, measurement error, giving you a simple example, is if your survey tool, if your questionnaire is not appropriate, then a measurement error can occur. It leads to the biasness in the results, biasness in data analysis. If the respondent is not in the right state of mind to answer your questions, or he or she might not have understood the questions properly, then also measurement error can arise. And measurement error is indicated by a small e along with all the indicators, whether it is an independent variable or a dependent variable in the model. Both of them can have a measurement error, right? Let us take an example. So if I say burnout of an employee in our organization leads to his or her turnover intention. Now, if you circulated the questionnaire and the employee had an argument with one of the colleagues or one of the seniors just before filling the response, he or she might shift his response from his true response to something which is being influenced by that argument. I mean to say, if you asked him to mark whether you feel exhausted by end of the day working in this organization, and you gave him 5 choices to mark on Likert 5-point scale, where 1 stands for strongly disagree and 5 standing for strongly agree. So you gave him a statement, I feel exhausted with my work by end of the day. So he or she might have an opinion which could be neutral upon this question. But having that argument turned his or her state of replying, and instead of neutral, he or she chose the response as 5, which is strongly agree. That means he or she strongly agrees that they are exhausted by end of the day. So this leads to measurement error, biasness in the results, which is failing to capture the true state of mind of that respondent. And is especially true in behavioral sciences, where we are judging people's opinion, we are taking responses upon their perception of a particular thing. It can change. It can be influenced by their state of mind or the environment or several other factors. Now let us talk about prediction error. Prediction error is marked as small d on the dependent variable, attached to the dependent variable. This means any of the prediction which you make through a regression equation, y is equal to a plus bx, a standing for intercept, b standing for slope, is not the true observed value, it's a predicted value. So there is a difference between actual and predicted value, which is known as residual. So this prediction error is the residual. So whatever you can do to include as many variables, independent variables, which will be explaining the dependent variable, still you have a scope of error which is known as prediction error. Say, now you ask the employee that do you want to quit the job, and again asked him or her to mark it on 1 to 5 on a Likert 5-point scale. Now again he or she marks quitting the job, where you have taken independent variable influencing the turnover intention as burnout, right? But maybe it's a possibility that he or she might be shifting the job due to some personal reasons. family reasons, maybe due to finding a better job, a better paid job in some other place. So it's not essentially that burnout intention is leading to that response of leaving the organization. So in this we see a prediction error comes, which is marked as small d on the dependent variable. So whenever you construct a model, a structural equation model, especially in IBM SPSS amos, you attach an error term to the dependent variable, which is known as prediction error. It is calculated as 1 minus r square. R square is coefficient of determination. How much variance in the dependent variable is explained together by all the independent variables in your model. So when you subtract this r square from 1, you get the unexplained variance, which is the prediction error. Now, what can be done to reduce the prediction error? So this is going to be quite interesting. This is where from we get the concepts of confounding variable or control variable. So let me tell you, any independent variable included in your study is known as a covariate. When that covariate is explaining its influence upon the independent variable as well as the dependent variable, in that case it is known as confounding variable. So all confounders are covariates, but all covariates are not confounders. Right? Let us take an example to understand this better. Say you are studying the effect of a health drink upon the height of a kid. Say any health drink which is popular in the market, its influence upon the growth, the height of a kid. So, do you think that only that health drink influences the height of the kid? Or there are several other factors as well which you have not included in your study. So, these hidden factors which influence the height of a kid, say for an instance the genetics of the parents, the exercise schedule of the kid, physical activity, they all influence height. But you are wanting to study the influence of health drink on the height. So, there is a prediction error. So, how to resolve that prediction error? We can resolve this prediction error by including control variables. Control variables are those independent variables which influence the dependent variable and have been investigated prior to you by other researchers in their studies. You do an extensive review of literature and find what all independent variables were there which were influencing kids' height and include them as control variables in your study to get the actual effect of the health drink upon the height of the kid. Now, say for an instance, you don't know. You are not aware of those control variables and you are not able to add those control variables. In that case, what you should do? Then we resort to finding out an instrumental variable. Now, instrumental variable is something which influences the independent variable and then the independent variable influences the dependent variable. So, instrumental variable does not have a direct influence upon the dependent variable. The effect passes through the independent variable, in this case the health drink. So, let us take instrumental variable over here, which is of course gotten through extensive review of literature. If you have the knowledge of your study domain, then only you will be able to find the instrumental variable, and you will have to include that in your survey questionnaire to capture the response on that variable, so that later you can use that instrumental variable. Or you have located the control variables, so you have to include the control variables in your study so as to get the response which can be analyzed later. Now, the instrumental variable, as I told you, influences the independent variable. So in this case, say the instrumental variable is proximity to the supermarket where health drinks are available, right? So how close is the kid's house to the supermarket where health drinks are sold? So when you look at it, we can say that those houses which are near to the supermarket, the parents are well able to easily get the health drink and kids can consume it, leading to their better height. This instrumental variable should have a strong correlation with the independent variable, should not directly influence the dependent variable, and the third thing is that this instrumental variable should be not related to any of the confounding factors. So in case we say that the confounding factor here is physical activity, confounding factor which affects both independent and the dependent variable. So in this case we can say physical activity, because physical activity, the more physical activity a kid does, he or she feels more likely to consume a health drink, and more physical activity also leads to higher height, better growth. So in this case physical activity is a confounding variable. But when I talk about instrumental variable, that is proximity to the supermarket, that is not having any relation with the confounding variable. There is no relation between proximity to the supermarket and the physical activity of the kid. So keeping in mind all these assumptions of an instrumental variable, we can use it to control the prediction error. Once again I repeat, when you add those hidden factors, hidden variables which might influence your dependent variable, by fetching them from the existing literature, you call them control variables. When you are not able to attach them or add control variables to your study, then you use an instrumental variable to study the effect of that independent variable, here in this case the health drink, upon the height of the kid. But instrumental variable has several assumptions, how you have to use it. So it is recommended that you first check your structural equation modeling through the assumptions of linearity, endogeneity and heterogeneity, and then start with the assessment. In case your data exhibits endogeneity, there is an endogenous independent variable which is leading to high prediction errors in your dependent variable. You cannot go ahead with the study. But how to find out easily that whether there is endogeneity present in my model or not? You can easily do this through the Gaussian copula approach available in Smart PLS 4. So I hope this session was quite informative and useful for all, and you will definitely share it with your friends and faculty colleagues. See you next time with some more informative content. Till then, thanks a lot.